Welcome to my lecture on limits. Let us first try to understand the meaning of this notation. Limit of fx as x tends to a is L. For this, let us take fx as x square, where x varies between 0 and 3. So in this case, 0, 3 is the domain where your x varies. Also, let's take, for example, the value of a as 2 in this case. As you can see that x has the liberty to vary on the x-axis. It can approach a from the right-hand side, or it can approach a from the left-hand side. Let's see what happens when it approaches a from the right-hand side. If it is approaching a from the right-hand side, the corresponding value of x under this graph fx, you can see approaches this number 4, which we call as the limit. Okay, because the corresponding value of 2 is 4 over here. Also, when x is approaching a from the left-hand side, the corresponding value of x, that is fx, approaches the same number, that is 4 over here. So we say in this case that 4 is the limit of fx, which is x square over here, as x approaches a. So I write it this way. I write it as limit of x square as x approaches 2, in this case, is 4. But what if you have a function that breaks at a certain point? As you can see over here, your function fx is a little weird. It is a parabola when x ranges from 0 to 1, and it is a straight line x minus 1 when x ranges from 1 to 2. So it breaks, the function breaks at the point 1 over here. You can see that the domain of the function over here is the closed interval 0 to 2, because x is varying from 0 to 2. If I try to make the graph of this function, it would look something like this. Let's take, for example, a as 1 over here. Let's see what happens when x is approaching a from the right-hand side. So if x is approaching a from the right-hand side, you can see that the corresponding value of x, which is over here, this is fx, it is approaching 0. So as you can see that x is approaching 1 from the right-hand side, fx is approaching 0. Let us try to approach a from the left-hand side now. When x is approaching a from the left-hand side, the corresponding value of x, which is over here in this case, is approaching some other point. As you can see that the corresponding value of 1 over here is this. So this is where it is approaching, which is kind of, I think, 1 square, because this graph is x square. Okay, so as you can see that there are two different limits in this case. So when x is approaching 1 from the right hand side, I can call it as, let's say, 1 plus, because right hand side corresponds to the positive x-axis, and I can see that the limit of my function here in this case is 0. So I write here 0. But what is happening when x is approaching 1 from the left hand side? I'll call it as 1 minus. I can see that the function is not approaching 0 in this case. It is approaching 1 over here. So I can see that there are two different limits of this function when x is approaching 1 from the right hand side or the left hand side. In this case, I say that the limit does not exist. I say that the limit x tending to 1 fx does not exist. So the moral of the story is the limit of a function as x tends to a particular number or x approaches a particular number exists if and only if the left hand limit, this is called as the left hand limit, the left hand limit is equal to the right hand limit. Please remember this. Okay, now the next question is, how do we calculate limit of a function? Let's take, for example, you are given a question. It's a very elementary question. You are given a question. Calculate the limit of x square plus 1 as x approaches 0. The first thing that you should try without hesitation is simply substituting the value of x as 0 over here in this case. So in this case, I'm getting the answer as 0 square plus 1, which is 1, which is the correct answer. So the answer was direct. You will never get such kind of questions in your exam because this is too elementary. Let us move on to the next question. This is not a straightforward question, because when you try to substitute the value of 1 in this case, the value of x, which is 1 in this case, you get a weird answer. You get 1 square minus 1 upon 1 minus 1, which is 0 upon 0, which is a wrong answer. So before you move on and do something stupid like this, first thing that you should do is try to simplify the function over here. As you can see, x square minus 1, you can apply the formula a square minus b square over here, and you can write it as x minus 1 into x plus 1. Now you can see that there is something common in the numerator and the denominator. You can cancel it out. Also, the reason for calculation here is when x is approaching 1, x never becomes equal to 1, which means that x minus 1 is never equal to 0. And that is the reason you can cancel the numerator and the denominator. Also another very important point to be noted. So all you are having right now with you is limit of x plus 1 as x approaches 1. Now you can go ahead and do the substitution that I had told you earlier. Here in this case it will be 1 plus 1 and the answer is 2. Okay, but my question is, what if you have something different over here? Let's say if it is a 20 over here in this case, then what would you do? I will come to that. Let's look at the next question. Limit of sin x as x approaches pi by 2. Can I substitute pi by 2 in place of x? Would you get anything weird in this case? No. You can simply write it as sine of pi by 2, and sine of pi by 2 is nothing but equal to 1. So these are extremely elementary questions on limits, but let's move ahead. What if you get something like this? What if you have limit of sin x by x as x approaches 0? If I try to substitute the value of x, I mean the point a over here in this case, I will get something very weird. I will get sine of 0 upon 0. Sine of 0 is nothing but 0. And I get a 0 upon 0 again, which is not the correct answer. Why? I will show you. For this, let us look at the graph of sin x by x. This is how sin x by x looks like. This is how sin x by x looks like. Let us try to see what happens when x is approaching 0 from the right hand side or the left hand side. As you can see that when x is approaching 0 from the right hand side, you can see that the function is approaching 1 over here. Similarly, when x is approaching 0 from the left hand side, the function again is approaching 1 over here. This is your sin x upon x function's graph. So the answer is not 0 by 0 or not defined or infinity or something like that. The answer is pretty clear. The answer is 1. Okay, so the answer here is 1. How do you evaluate this answer without using a graph is another point of discussion. Let's move on to the next. So this is one standard formula that you have to make a note of. This is the first standard formula. There are 4 standard formulae of limits which you need to always remember. Let's move on to the next standard formula. The next standard formula is limit of x raised to n minus a raised to n upon x minus a, where x approaches a. A few moments ago, I had posted a similar question. There I had written n as 2 and I had written a as 1. But I had also asked you the question, what if your n is 20? So this takes care of all those, kinds of doubts. So what is the answer to this? Let's take, for example, again, n as 3 and maybe a as 2. And let's see how the graph of the function looks like. So the graph of the function x raised to 3 minus 2 raised to 3 upon x minus 2 looks like this. What happens when x approaches 2? As you can see, when x is approaching 2, you can see 2 over here on the x-axis. And let's see the corresponding value of the function under this x is equal to 2. You can see that the corresponding value of x is equal to 2 is 12 over here. So when x is approaching 2 from the right hand side or the left hand side, the function is approaching this number, that is 12. So the answer is 12. But how do you take care of 3 replaced by n and 2 replaced by a? So there is a standard formula for this. It is n into a raised to n minus 1. Let us verify this answer with what we just solved right now. In our case, a was 2, n was 3. So I have something like this. According to this formula, it should be 3 into 2 raised to 3 minus 1. So whatever you write here, it should be 1 power less over here. So the answer should be 3 into 2 raised to 2, which is 4. So the answer should be 12, which is exactly what we discussed right now. Let us move on to the next question. Sin x by x as x approaches 0. We just now dealt with this. Let's move on to the next one. Let's see what happens when you deal with this kind of weird function. This is another weird function. If you try to put in 0 in place of x, you get something very weird, because you will have 1 plus 0 the whole raised to 1 upon 0. First of all, 1 upon 0 is also not defined, and you cannot find this out. But still, the graph is not so not defined. Let's look at the graph. So the graph looks like this. 1 plus x the whole raised to 1 by x looks like this. And as you can clearly see that when x is approaching 0, either from the right hand side or the left hand side, the function is approaching a particular number. You can see it is 2.715 or 718 or something like that. Okay, so this is nothing but one of the very famous numbers, irrational numbers, which is called as the Euler's number, E, which is 2.71 and so on. It's a never-ending decimal. So the answer here in this case is E. Remember this. This is another standard formula which you should always remember. There are several versions of this formula, but this is the basic version of all the formulae. The next question is about limit of a raised to x minus 1 upon x as x approaches 0. What is the answer for this? The answer, again, if you try to plug in 0 in place of x, you will have something like a raised to 0 minus 1 upon 0, which is 1 minus 1 upon 0, which is 0 by 0, which is not the correct way to do it. So here, the answer, I will straight away give you the answer. It is log of a to the base e. So in case if you have something like limit of e raised to x minus 1 upon x, where a is replaced by the Euler's number that you just now saw, the answer would be log of e to the base e, which is nothing but 1. So let's try to verify this again with the help of a graph, which I have made through Desmos. So e raised to x minus 1 upon x looks, I think I had zoomed in a lot. Let's zoom out. Yeah. This is how the graph looks like. E raised to x minus 1 upon x. As you can see, when x is approaching 0, you can see that the function fx is approaching 1. So either from the left hand side or the right hand side, the function fx is approaching the same number, which is 1 in this case. So the answer for the limit is 1, which is right. So remember, these are the 4 standard formulae. One is limit of a raised to x minus 1 upon x as x approaches 0 is log of a to the base e. Note this down. Another one is limit of 1 plus x the whole raised to 1 by x as x approaches 0 is e. Another one is limit of sin x upon x as x approaches 0 is 1. And the fourth one is this one. Limit of x raised to n minus a raised to x raised to n minus a raised to n upon x minus a as x approaches a is n into a raised to n minus 1. These are the 4 standard formulae that you should remember. Now, let us try to solve a few problems. The first one is limit of 1 plus x under root minus 1 upon x. How do you solve this? As I told you earlier, the first thing you should do is try to substitute the value of x, the a over here, which is 0, in place of x. So you will get root of 1 plus 0 minus 1 upon 0, which is again in the 0 by 0 form. And hence you won't be able to proceed. So you should try to do something which will get rid of the x over here. And that is possible by rationalizing. You can simply multiply the conjugate of the numerator above and below. So using the formula a plus b into a minus b, which is equal to a square minus b square, you will have a simplified version of this. It is 1 plus x under root the whole square, which is going to be 1 plus x, minus 1 square, which is 1, upon x into this number, this expression that you have over here. Now you can see that the 1 and the minus 1 gets cancelled, x and the x also gets cancelled because x is tending to 0 and it is never going to be equal to 0. All you are left with is just this denominator, root of 1 plus x plus 1. Now can you try to substitute the 0 over here in place of x? Yes, you can definitely. You will get root of 1 plus 0 plus 1, and the answer is going to be 1 upon 1 plus 1, which is 1 by 2. Okay, this was a very easy problem. Let's move on to the next one. Limit of x plus 2 the whole raised to 5 by 3 minus a plus 2 the whole raised to 5 by 3 upon x minus a as x approaches a. As you can again see that the formula that we are going to use is of the first standard formula that we just now saw, limit x raised to n minus a raised to n upon x minus a as x approaches a. It's going to be n into a raised to n minus 1. The only difference between this formula over here and the given question over here is that the x is not so direct. In place of x, you have an x plus 2. In place of a, you have an a plus 2. In place of n, you have a 5 by 3. That's fine. But you can also note that whatever variable you see over here also should appear over here. Whatever constant you see over here should appear over here. In this case, this is not the case. It is x plus 2 here in the numerator, but it is x here under limit. It is a plus 2 over here and it is a over here. But that is again kind of obvious because if x is approaching a, if I add up 2 on both sides, I can say that x plus 2 approaches a plus 2. Also, you can see one more thing, that whenever there is a variable x over here, there is x over here. If a is over here, there is an a over here. In this case, there is an x plus 2 over here, but there is an x over here. A plus 2 over here, and there is an a over here. Which is also kind of very simple to explain because, x minus a can very well be written as x plus 2 minus a plus 2 because the 2 and the minus 2 gets cancelled. So now I can rephrase this question as limit x plus 2 tending to a plus 2, x plus 2 the whole raised to 5 by 3 minus a plus 2 the whole raised to 5 by 3 upon x plus 2 minus a plus 2. Now if I try to substitute or use the formula that I just learned, apply it on this. Since my n is 5 by 3, I write here 5 by 3. The a over here is not just a, it's an a plus 2. And on top it should be 5 by 3 minus 1. So the final answer is 5 by 3 into a plus 2 into 2 by the whole raised to 2 by 3. And that's your final answer. Let's move on to the next question. Limit of 1 plus sine x the whole raised to 1 by x as x approaches 0. Again, you might have already understood that the formula we are going to use here is limit x approaches 0, 1 plus x the whole raised to 1 by x is e. But the only problem here is that if you see an x over here, this x should appear in two more places. So it should appear over here. Also, it should appear over here in the denominator of the power. You can see that the variable here is sin x and not x. So if a sin x is over here, you should see a sin x over here. And also there should be a sin x over here. Now we can take care of this part because I know that if x approaches 0, then sine of x also approaches sine of 0. If x approaches 0, then if I apply sine on both sides, sine of x approaches sine of 0, which is nothing but 0. So I can very well replace this part by sine x approaching 0. But what about the power over here? I cannot replace this x simply by sine x over there. So for this I will have to do a slight adjustment. I will have to rewrite this as, first of all, limit as sine x tending to 0, 1 plus sine x the whole raised to 1 by sine x. Now you might be wondering where this sine x has come from. I have just deliberately put it over there. So if I have put a sin x over here, I'll have to cancel out the sin x by raising it to the sin x power using the law of indices. But what happened to this x? I'll have to take care of that x also. It has not disappeared anywhere. It will still remain over there. So you can see that if I cancel the sin x and the sin x over here, then I get the question again. So this is the adjustment I was talking about. Now I can very well apply this formula inside the square bracket and I can get the answer as e. But there is something more left to be done before I apply the formula. What happens to this? You can't simply write it as e raised to sine x upon x. In the answer, the x variable should never appear. It should always be a number. So we apply one of the properties of the limits over here. I apply the limit on the numerator as well. So I'll have to write one more step. 1 plus sine x, the whole raised to 1 by sine x. And the whole raised to limit x tending to 0, sine x by x. I can, if you are still wondering where this x tending to 0 has come, it is the same limit that I'm talking about here. Now you might be wondering why I have written sin x tending to 0. Sin x tending to 0 is same as saying x is tending to 0. There is no point in writing sin x tending to 0 over here because I want to use my standard formula. Okay, so now the answer is very clear. Here it is e and on top it is 1. So it is e. Let's move on to the last problem. Again, this does not seem to be one of the standard formula, but you can always bring it in those form. So you might have already got a hint that the formula that I'm looking for here is limit of a raised to x minus 1 upon x as x approaches 0 in this case, and that's log of a to the base e. But the question is not in this form. So how do I bring it in that form? The first thing that you can do is apply law of indices, write that 5 raised to minus x as 1 upon 5 raised to x. So it becomes 1 upon 5 raised to x minus 2 upon x square. Moving on, thus becomes, if I try to multiply the 5 raised to x, I get 5 raised to x the whole square plus 1 minus 2 times 5 raised to x. This 5 raised to x also goes to the denominator. Now as you can see that this is of the form a square plus b square minus 2ab, which is nothing but a minus b the whole square. So let's try to apply that formula. So limit x tending to 0, 5 raised to x minus 1 the whole square upon x square. Let us try to keep this 5 raised to x aside. As you can now see that this is very well in this form. I can now apply the formula. So I have to write it as limit x tending to 0, 5 raised to x minus 1 upon x the whole square. Limit of a square is square of a limit. So I can write it this way. Also this limit can be applied on 1 by 5 raised to x. So it becomes limit x tending to 0, 1 upon 5 raised to x. This is not a standard formula, but you can just try to substitute 0 in place of x and you will get 1 upon 5 raised to 0. And on this side, the answer is simply log of 5 to the base e. And on this side, it is 1 upon 5 raised to 0. So the answer is log 5 to the base e. Also sometimes written as natural log of 5. That's it. So you can try solving many more examples and gain your confidence on this very basic chapter called as limits. I have tried to cover up all the problems, all the types based on the 4 standard formulae that we just saw. So always remember these 4 standard formulae.